Hi everyone, Krishna this side. So in this video, I'll be covering this Leetcode problem 3333. Find the original typed string 2. So yes, I already tried making a video which was around 54 minutes long, but there was a problem while uh, recording this particular video. The screen got paused in between, and only voice got delivered after half of this video. So yes, again I'm reconsidering it to upload the video. Okay. Yes, please make sure to subscribe to the channel because a lot of efforts are required to make these videos, and I noticed that only 4% of people you guys have subscribed it. So yes, please make sure to subscribe to this channel if you find this solution acceptable. Okay, so let me try to explain this again. And in this particular time, if again there were some issues, if I notice, the video might not be there at all. So it's an hard problem, yes, and of course we have to put some extra efforts to solve this particular one. I'll try to make it simple to understand. Okay, so let's try to see what is given to us and what is been asked. Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. You are given a string word which represents the final output displayed on Alice's screen. Okay. You are also given a positive integer k. So we have to return the total number of possible original strings that Alice might have intended to type if she was trying to type a string of size at least k. Since the answer may be very large, so we have to return it into the modulo. Okay. So if this is the word that has been given, the key value is basically equals to 7. So at least 7 length of character string we can have by removing few of the characters, and that is whatever the possible strings that we can get it, that is something what the count, basically we have to write it into the output. So here A appeared 2 times, B appeared 2 times, C appeared 2 times, and D as well appearing 2 times. Okay, so the length of the string is basically equals to 8. So yes, I can just remove one character to achieve k equals to 7 or more than that. Okay, so yes, we can simply remove a character, then the length basically equals to 7, and that is acceptable. B from the B also we can remove one character, and whatever the resultant string that is been formed, that is also another answer. Same goes with C and D, and entire string itself is going to be answer. Okay, so in total 5 different strings that we can get it, which with which we can generate possible solutions. Okay, so yes, without any further wasting any times, let me try to connect to the string this screen, and I'll explain you the solution right over there. I hope the screen is visible. Here A actually appeared 3 times, B appeared 2 times. Okay, and k value is basically equals to 3. So without considering these three, how many different possible combinations that we can form with the help of these strings, right? Whatever the string is being given. So each character should be appear at least once, right? That is the clarity that we have, because she was started typing that character, and without unintentionally that character got typed multiple times. Okay. Yes, the characters at least we have to consider once, and then again B also I can consider it. Next is like double A B. Next is like 3 times A B. Apart from this, like A double B and double A double B, and it is like 3 times A 2 times B. Okay, all these different strings that we got are different solutions that could be possible answers. Okay, so the first is like here k value is basically equals to 3. So whatever the strings that we are generating, its length should be at least 3 or more than that. Those all the strings are possible answers. Okay, but if we look right over here, AB is not a valid string, right? Because its length is basically equals to 2 and k value is basically equals to 3. So this is not a valid one. Next one is like double AB. This is valid, this is valid. All I mean whatever the strings that we saw right over here, all those are valid strings. Just one string is not valid. When k equals to 4, at that point in time, this is invalid, this is invalid. Okay, so in total 3 answers, 3 is the string answer that we are getting it. Okay, so I think this should be clear for us. Okay, so now to get all these counts, how we are getting this count generally, if we try to see right over here carefully, the A basically appeared. We can use of this A in this fashion, like A once time we can once we can use it, double A or triple A, we can use all of them. Next is like with the B, either we can use single B or double B, and by just simply considering all of these different possibilities, we can get the answers. Okay, so in total it is like here 3 possibilities, here 2 possibilities, so it is like 6. 3 cross 2 is basically equals to 6. Okay, 6 different strings is something what we are getting it, and that we have seen also right over here. Okay, so if there are more characters like A, B, B, C, C. Here it is like 2, 2, 2 in total. It is eight different strings we can generate it. Okay, the moment we generate it, okay, so we just have to now figure out like how many strings that are invalid strings. Okay, because with this one we are actually getting all the different possible strings that we can get it out of this one. Okay, this particular string. Now the question is like how to just figure out the invalid strings. If we able to figure out the invalid strings, we are done. Like we can simply return the answer. Okay, so here from this one, if k equals to 4, three strings are invalid, so in total six strings were there, and when we subtract 3, 3 is the answer that we can get it easily. Okay, that should be the clarity that we have till this point in time. Okay, so yes, now the question is like we just try to figure out the invalid strings. Okay, okay, another watch, if we try to carefully see right over here, when k is actually equals to, let us suppose k is actually equals to 2. Okay, when k value is equals to 2, all the values that the strings that we have generated are all valid one. Okay, because length is actually equals to 2, the first one is actually valid. Okay, the ab, then there is like a double, I think double ab. Okay, so whatever it may be, so all the strings that we have generated are valid one, because k value is basically equals to 2, and the least string that we can get which is having length equals to 2 is valid one. So anything that we generated further going ahead, all of them are also valid one. So the first thing that we will try to see is whenever the k value is been there, we will just simply check that how many characters that we have here. Two characters that we have, different characters. Okay, and this with the help of different characters only we can generate the least string. Okay, which is like ab in this particular case. So its length is basically equals to 2 and k value is equals to 2. So whenever the k value is equals to 2 or less than this value, okay, 2 or less than this value, okay, at that point in time, whatever the count that we got, simply by just considering like a appeared 3 times, b appeared 2 times, 3 cross 2 is 6. That is the answer that we can simply return. Okay, that is the answer we can simply return. When the value k is actually more than this, whatever the counts that we have, okay, length than this, that point in time only we have to just figure out the invalid strings. Okay, and yes, to figure out that one, let me just demonstrate with a few of the examples. We will start with the pretty much easy one. Let us start with something like this, double A. Okay, 5 times A is something what we have. A value is basically equals to 3. So with this one, how many strings we have? A, double A, triple A, 4 times A, and then it is like 5 times A. Okay, all these different possibilities that we can get it. And k value is 3 means this particular one, this particular ones are invalid one. Okay, only these are the valid strings that we can have. Okay, so instead of trying to figure out like which are the valid one, we will try to simply figure out which are the invalid one by starting with the zeroth index. When k value is basically equals to 3, all the values from the k value 3 to whatever the strings length that we have, all those are valid one. Below that, those are invalid one. So what we will do, we will start with this k equals to 1, k equals to 2. We'll try to generate answers. Okay, we'll try to generate answers when k equals to 0, and this is the string that we have, which is having a equals to 5, the count of a. I cannot consider any character at this point in time because k value is equals to 0, so 0 possibilities that are there. Okay, 0 characters I can consider at this particular point in time. Just try to focus right over here, what I'm trying to say. You will get the idea what I'm trying to say. Okay, so a is 5, and when k equals to 0, I cannot simply consider any characters at this point in time, so 0 characters I have fixed at this location. When k equals to 1, okay, if let us suppose this is the string that we have and k equals to 1, I can simply consider a, right? This is the valid one, that is going to be pretty much sure, correct? So yes, I can fix a as a character, so that is like one possibility is there. Okay, one possibility is there, one count is going to be there for sure when k equals to 1. When k equals to 2, here a value is basically equals to 5, so two characters I can easily pick 2a. Okay, here also one possibility is there, correct? When k equals to 2, one possibility is there, that is like double a. Okay, this is clear, right? So if k equals to 3, 3 times I can use a, and 3 values of a I can fix right over there, because we have a is 5, and so far we are within a limit. We can easily use that many a's to form these values. Okay, so we simply have, this is the string that we have given, 5 times a. When k equals to 1, we can fix actually a. When k equals to 2, we can fix 2 a's. Okay, that is one count, two counts. Okay, these counts we are getting it. Okay, apart from this, do we have any other possibility? No, right? Like we can simply fix two double a's, and that's all. Like for k equals to 2, if k equals to 2 is given, So only wrong answer is like single A. Apart from that, all the answers are correct one. Okay. So what we are trying to do is we are trying to go till k equals to k minus 1. Okay. K minus 1, and we are trying to figure out when k equals to that particular value. Here k equals to 0, we can fix 0 characters. When k equals to 1, we can fix 1 character. Okay. When k equals to 2, we can fix double A as a string. Okay. This is valid string, right? This is the valid string. So yes, there is also one possible answer that we can get it right over here. Okay. So far, when k equals to 2, how many how many ways we are actually fixing this character? So it is like 0 plus 1 plus 1, it is like 2 in total. Two different strings that can be formed when k equals to 1 and k equals to 2. Okay. So what we are trying to do is, below this k equals to 3, whatever the k value has been there, for that particular one k equals to 2, how many strings that we can generate it, which could be definitely these, all the answers that I am generating right over here are invalid one. So if I try to add them, when k equals to 1, one single character has been there, that is something what I have to consider. When k equals to 2, characters, I can fix it easily because a is basically equals to 5. So yes, I can simply, if we add them, 0 plus 1 plus 1, basically it is going to be 2, and two strings are basically invalid one. So in total, if there are like five strings that we got, 5 minus 2, if we do 3 is the answer that we can simply get it. Okay, this should be clear, right? So yes, 3 is the actual answer that is there. When k equals to 4, again we will try to see k equals to 3. Till that point in time, we will see again here like double triple A is something what we can fix it, and that is again another possibility that we can have. Okay, so in total, like if I simply add it, like 3 triple A's, three different strings that are there. When k equals to 1, there is one possibility. When k equals to 2, there is another possibility. When k equals to 3, there is like triple A as characters that we have, which is another possibility. Okay, with the help of these all different, when we simply add them, whatever the answer that we are getting it, those are like invalid strings that we have, because k is basically currently 4, and below that 4, below whatever the length that we get, we are just trying to generate the strings. We are just trying to generate the strings, and we are checking it if that string is possible or not. If it is possible, we are simply considering it as a count. Okay, this should be clear. If it is not getting clear, further going down, we are not going to understand what I'm trying to say. Okay, at least I'm just, whatever I'm trying to say, k equals to 1, we can create one string out of given whatever the count that we have. K equals to, so we can simply create it. Okay, so that should be clear for us. Okay, just let me again connect it. Okay, I hope the screen is visible. Now let's try to take this particular one with big big example. Okay, let us suppose that a is, this is the string that is been given to us. A actually appeared 3 times, b actually appeared 2 times, correct? And k is basically equals to 4. These are all different possibilities that we can get it. In total, it is like 3 cross 2 is basically 6. So in total, 6 possibilities that we can have. Okay, it's this one. It is like 3 cross 2. In total, 6 possibilities that we have. Now k is basically equals to 4. So what are the invalid one? This one is the invalid one. This one is invalid one, and this one is okay. So length k equals to 3. Below that, whatever the strings that we get it, those are invalid one. So we will try to generate all those strings, right, with the help of this particular one. Okay, and yes, this particular problem basically falls under unbounded knapsack. Okay, so there are like 0 on knapsack, either we consider it or no consider it. Okay, and this in this particular one, we will try to generate all possible solutions by considering the weights. Okay, so k is basically, you just have to consider it as a weight currently. So to form this 4, before 4, like till going till 3, how many different strings that we generated, those strings are basically not considerable for our case, so we simply omit them. So that is the count we have to figure out. So how we will do it? Initially k equals to 0. Okay, initially k equals to 0. Here it is basically 0 at this particular point in time, because when k equals to 0, we cannot simply consider any character, right? So that is the idea over right over here. So we cannot fix any character right over here. When k equals to 1, okay, now I can fix a as a character. A as a character, because a value is basically equals to 3. So I can fix right now a as a character. So here the count is basically 1. So to get this one, okay, to get this one, we should generate some formula. Okay, so we are actually relying on previous value and from the above previous index. What I'm trying to say is, so I if I want to generate this value, okay, I should be either relying on this one or relying from here. So here there should be another array. Okay, whatever these values that I am generating right now, this should be put in another array. Okay, for this particular one, whatever the answers that I have generated previously, all of them I actually summed them up. Correct, I actually summed them up to get the total how many different uh, strings that we got at each k value. Okay, so yes, we should maintain this in particular array so that we can get their counts. Okay, so the idea is pretty much clear now. So let me just clean this up, whatever the mess that I have created. So this, to get this one, okay, to get this one, basically we are relying on these values only. So whatever this a double a, those possible strings that I am generating, it is just to get understanding purpose. I am just basically writing those strings right over there. Okay, so what I'll do is right over here, let's say that we have another array which is initially filled with 1 and all the values basically got filled with 0. Okay, so this array is basically again starting from 0 1 2 k equals to 2 k equals to 3. Okay, same array. Again we are generating similar kind of array right over here at this location as well. Okay, so to initially get this value as a 1, okay, initially to get this value as a 1, I should basically getting it from here or from here. So initially this value is basically 0. Okay, because k equals to 0, I cannot consider any character at that point in time, so it is basically 0. When k equals to 1, yes, I have this 1 as a as a character as possible answer. Okay, yes, I can simply consider it. So to get this answer, I can simply just create another array. This we can name it as a dp array. So initially it will be having at 0th location 1 value is there and all values are basically filled with 0. So I can get it from there or here, and the answer could be like, if no characters we are considering, okay, there at that point in time one answer was there. So 1 is something what we directly got it. When k equals to 1, a is the character that we can consider. No character plus one character, a character is basically 1, right? Yes, that is the idea. I mean, we can consider it in that way. Okay, now for double a, again from here or from top, I can get the answers from here or from the top. Okay, top is like basically k equals to 2, k minus 1 is something what I'm looking at for. Okay, why I'm looking, that you will get the idea about when we will start looking for the b. Okay, so see, now I am just curious about when k equals to 2. I just want to fill these values. Okay, so when k equals to 2, I will try to get the answer from left side or from the top. From the left side, we already have one A. Okay, we already have one A. So with that A, if I add another A, I can easily create the string which is having length equals to 2 and k is basically equals to 2. So yes, this will basically get satisfied. When k equals to 2, I have another possibility, and that possibility got generated from the left side. Okay, from the left side, because there was already one A. With that A only, I just added another A. So from left side, the count was 1. So here also the count was 1. Okay, and from top it was 0. So 0 is basically representing 0 only at this point in time. When k equals to 3, again I can fix 3 characters because we have those many characters in our purse. Okay, so yes, I can fix 3 characters. So from the left only I got the answer, because double a plus a, when we do that, triple a is something what we get easily. Okay, so yes, triple a is something what we got right over here. So it is in total 3. I mean, one possibility is there, again fixing this triple a's. Okay, I think this should be fine. At least at this point in time, you don't get the idea. But when we start filling this B, you will get the idea. Like, okay, this is why we are doing it, right? So yes. Now this particular first array has been completely filled. We reached when k equals to 3. We reached because k equals to 4. Below k equals to 4, whatever the possible strings that we get, that is something what we are trying to figure out. With the A, we actually fixed all these characters in each index, and we tried to get how many possibles we possible solutions we can get it at that point in time. Okay, when we start filling b, k equals to 0, here it is going to be 0. K equals to 1, can I consider here b as an individual character? Can I simply consider? Now the dp array, whatever the previous dp array that we have, dp should start pointing to this one. Okay, so these all values should be now filled with this dp array. Okay, this should be our new dp array, whatever the dp array that we have created. Okay, these values, new values, is something what we have to consider right now. Okay, now the question is, here it is, like, let me just fill this double a triple a. Okay, now the question is, can I simply consider single b at this location? Because k equals to 1, I can simply consider b as individual value as well, right? So b can be there, but is it a valid solution? Because at the end, now we are at last index, and we have to make sure that whatever the previous characters that we have computed already, with that only we should generate the string. Because individually, did we ever notice right over here individual b is also appearing right over here? No, right? For this one, individual a was appearing because we don't have any other characters apart from a. We don't have any extra characters apart from a, so this was valid one. But individually a single character can it be a representable string? No, right? So we have to make sure that whatever the previous characters that we have, those characters should appear at least once. They should appear at least once. So here I cannot simply consider b as an individual value. And to justify that, here from the top it was 0, from the here it was 0. So 0 is something what we got. So whatever the count that we are getting it, we are simply adding it. Same thing that we have done with the previous array, whatever the previous array that we are forming. Now at this location it is like 0. We cannot simply consider a single b when k equals to 1. K equals to 1, okay, at that point in time. And this was getting generated from this index, k minus 1 index, and the adjacent value, okay, whatever the adjacent value that we have in this one. At this particular index, okay, again let me just clean this all the things. At this particular index, again from the top this index and from this one index, I can get the answer. So whatever the answer that we got from the top, it was 1, here it was 0, in total one string that we can generate, which is having k equals to 2 as a length, and that could be taking this a and taking this b as 1. So it is like ab is the string that we can generate right over at this location, right, which is just basically satisfy this k equals to 2, k equals to, because this length is actually equals to 2. Okay, so from the top k minus 1, whatever the value that we have in the dp array, it was 1, and from here it was 0. When we add them, whatever the count that we are getting, the count is something what we have to maintain it. But to just to understanding purpose, it was like from the top we got 1, right? With that 1 we just simply adding b, this b character, because we have two b's with us, so we simply can add one b into that one, whatever the previous a, because here a's count was 1, and here we have to make sure that length is actually equals to 2. Okay, so a and b's length is basically equals to 2. From the top, whatever the character that we retrieved, it was 1, and from here we have no characters, no strings that we got retrieved, right? So 0 is the answer that we got it from the left. Okay, so again to generate right over here at this location, from the top and from here, whatever the characters that we get, okay, it was from the top, it was aa, so a with aa I can add b. From this left side with ab I can I can add b. I can simply add b, right? With the ab I can simply add b. Only a single character is something what I am adding it each time, so that to justify this whatever the length is being given, I just want to make sure that whatever the length is being given, we should justify to that length. Okay, so at this point in time, here there are two possibilities. It is like from the top, whatever the strings that we have aa, with that I can add b. From the left, ab is something what we have, I can add b into that. So in total two possibilities are there. It is like simply, okay, from the top 1, from left side it is 1. In total two possibilities that are there, and those are aab and abb. Okay, once we are done with the k equals to 3, we are done, we simply come out of it. Now whatever the last dp array that we have created, the dp array values are like 0 0 1 2. Okay, here at this for 1 it was like ab, here it was like aab, abb, correct? These are the strings that we have generated. We can simply add them, because whatever these values that we got, three strings that we got which are invalid, and those strings, if we try to match it like ab, it is like aab, abb, correct? Those are the strings which are invalid one. At the top also, if we try to notice, here it was like ab, aab, a double b, and we tried generating those only. So simple thing that we are trying to do is whatever the k minus 1 value index, whatever the value dp value that we have, we are simply considering it. From the left also, whatever the value that we are getting it, we are simply considering and adding them at this particular location. So from here top it was 1, from here it was 0, so 1 is something what we got. From top it was 1, from left it was 1, two strings that we can generate. Okay, and those strings could be this one. Okay, just to understanding purpose, I have added those strings as well at these locations to get the clarity like how this strings that we are generating, okay, till k equals to 3. Okay, so for k equals to 3, these two different strings that we can have which are invalid one. For k equals to 2, this is one string that is invalid one. K equals to 1, we don't have any invalid string because b itself is not valid string, we cannot consider as well. So for this one also, from here and here, whatever the counts that we have, we are simply adding it right at that location. Okay, I hope now this gives a clarity. We will start with one last example, and that should clear all our doubts. And for last example, we will try to make sure that this k value, whatever has been there, the count here so far, we are not gone out of this, whatever the count value and this k value has been there. those are basically justifiable, because triple with the triple a I can form this one. The moment when k equals to 4, I cannot fix 4 a's, right, because we have only 3 a's with us. Okay, that is the only condition that we have to consider right over here. Just let me charge it, and immediately I'll back and I'll explain you, and then we can start writing the code. All right, so let's try to focus on this particular one. So let us suppose that if we have this as a string that has been given double a double b. Okay, let me just change the color, and k value is basically equals to 4. So in this particular one, all these length less than 4 are invalid one only. This is the correct answer that we have. Okay, so we'll again start filling this one. So initially the dp array, whatever the dp array that we have created, it got filled with this one. Okay, so k equals to 0 at 0th index, 1 has been there, because when k equals to 1, this character is something what when I try to consider, I should get 1 as value, right, because that is something what I'm fixing it right at this particular moment. So what we will do is, again we will see k equals to 0, 0 characters, no characters we can consider from a, so 0 where is possible, we cannot fix any character. When k equals to 1, we can fix one character. Okay, and the simple idea is like we will simply get the count from here, count from here, we will just add them, so it is like 1. That is the answer that we can get it. And if we try to think about it, like how we are getting it is like basically single a is something what we have fixed right over here at this location. Okay, now next is like again from here and from here, whatever the count that we are getting in total, it was 1, 1 plus 0 1. So again double a is something what we can fix it easily. When k equals to 3, okay, k equals to 4 is something what we have given, so k equals to 3 is also we have to figure out. When k equals to 3, is it possible to fix 3 characters? Because a is basically equals to 2. Okay, it's not possible to fix 3 characters right over here at this location, right? So that's where sliding window technique is something what we have to use. Because so far what we are trying to do, whatever the previous possibles that we are getting it, we are simply considering them for the future use cases. Okay, right here, right over here at this particular location, I cannot simply create fix 3 characters at this location. So what I can do is, when k equals to 3, I'll simply jump at that particular index from where it all get started. So I have to make sure that the window size that I am considering is basically following this whatever the value has been given to us. Okay, so a is equals to 2. So what I'll do is simply k minus, okay, the formula is basically the moment we realize that this whatever the counts that we have, a's count, b's count, if it is actually falling less than this k value, okay, that point in time what we will do, k minus this count. Okay, let us suppose count is something what we have currently, a's count, b's count. Okay, k minus count minus 1. Okay, in that particular dp index we jump it, whatever the value that is there available, we will simply subtract it right over here. Because see, again at this location, just for consideration, we are simply doing all the same operations again. We simply consider it. Okay, previous value, and here whatever the answer that we got, 1 is the answer that we got. Okay, and let us just think about this. What if the string is basically equals to a. Okay, two a's are there and k value is basically equals to 4. Okay, k value is basically equals to 4. This is the string that has been given. The answer could be 0 in this particular case. Okay, this is for this answer, like string double a, 2 times a is basically appeared, k value is basically equals to 4. For this answer should be equals to 0, because a string we cannot form 4 characters, 4 length string, right, because it is basically going out of the bound. But in just in this particular case, when k equals to 4, is it possible to form a string having length 2? It is not, right? So of course, when we go further ahead, we have to make sure that whatever the count that we are getting it so far, those counts we should simply start subtracting it. Okay, so dp of k minus count minus 1, if we try to look, it is like 3 minus count is basically 2 minus 1, it's like dp of 0. Okay, so dp of 0 is something what we get. So at the dp of 0, the value is basically 1. So 1 minus here, it got 1 from here, and here when we add it, 1 is something what we got. 1 minus 1 is basically equals to 0. When k equals to 3, at that point in time we cannot fix these characters. So whatever the characters that we have, those characters should be there. A should be there no matter what happens, because we have to consider those characters, but we cannot fix the characters at all. 3 characters we do not have with us. So simply 1 minus 1 is something what we will do. Whatever the dp of k minus 1 minus 1, whatever the answer that we got at this location, we'll subtract that value. Okay, so the answer is basically 0. Okay, for k equals to 4, k equals to 3, answer is basically equals to 0. And so far, if we try to add them, 0 plus 1 plus 1 plus 0, it is like 2. This value is basically equals to 2. Okay, and from this string, double a string, whatever the double a string that we have, how many possible strings that we can generate? It is like a or double a. Two strings we can generate. 2 minus 2, when we do, the answer is basically equals to 0, and that is something what we have to return it right over there as well at that location. Okay, if we haven't done this one, okay, if we haven't subtracted this dp of k minus count minus 1, whatever the answer that we are trying to generate, dp of k minus count minus 1, okay, in that case here it is like 3, here it is like 3 values something what we get, sorry, here it is like 1. So in total when we add all of this 1 1 1, the answer is basically 3. 2 minus 3, if we do minus 1, is the answer that we get it, right? So one extra value that we are considering, it should get subtracted from here. Whatever the further consideration that we will be having, we should consider a smallest, whatever the window size that we have, the count size that we have. So at any point in time further going ahead, we simply subtract k minus count minus 1 at any point in time when this k value is actually greater than this counts value. Okay, that is the simple change that we have to consider right over here, so that no overlapping strings we can consider, because here double a is something we already consider, and again double a if we try to consider, it is like same string we are considering two times. Okay, so yes, whatever the answer, max answer that we can get it, we actually already achieved it, so we have to simply subtract the window size going ahead. Okay, going ahead we have to simply subtract each characters. So for k equals to 3, we have to subtract this value. K equals to 4 for 5 and all, going ahead we will simply dp of that value minus whatever the current answer that we have, that is something what we have to subtract. Okay, so going ahead all values are getting filled with 0 0 0 0 0, something like that. Okay, this is something what the clarity we should have now. Now the moment it has been done, okay, let me just clean this up, all the things that means that have created right over here. Okay, so at this location aa is going to be there, but the count that we should get is 0. Okay, so this is the new dp that we have. Okay, new dp that we have, with the help of previous dp we have generated this new dp, and its values are like 0 1 1 0. Okay, let me just clean this all the things. Its values are basically 0 1 1 0. Okay, these are the values that we have in this uh, current dp. Now we will look for the next character. So next character is basically b. So k equals to 0, 0 is something what we have. Again, I already explained you, b simply we cannot consider at this moment. So we have to form a strings with the help of previous characters only. Okay, it should be ab or something like that. So I cannot at this location, I cannot form ab string like, because k value is basically equals to 1. Okay, so here it is going to be 0 again, and that 0 is basically come from here and here. Okay, 0 plus 0 is something what we do. So 0 is the answer that we get it. Okay, so that's the simple formula that we will apply. So 0 is the value that we get at this location. This 1 and 0 is something what we will add it. It is going to be 1. So it is like AB is the string that we can generate it at this location. Just to getting clarity, I'm just writing this down. Again, 1 and 1. Here it is like 2. So it is like AAB or ABB. Okay, these are the two different strings that we can generate it. Going ahead, k equals to 4, if we again started going ahead, there also we will have the same issue, because now here b's limit is already done at this location. With this one we can generate it, but with this one we cannot add any extra b's. Okay, so if we try to generate when k equals to 4, let us suppose k equals to 4 is again there, length is something, 5 is something what they are trying to look for. Okay, 5 is something what they are trying to look for. So at this location here it was 0 for a equals to 2, for b equals to 2, at this location how it will be. Okay, so previously it was 2, at this location it was 2, and at the top it was 0. Okay, at the top it was 0. So from here and here the count basically we get, so it is 2, overall count is basically 2. And how this strings basically forms, so previously at this location it was aab and abb. Okay, here it was aa, here it was aa, that is basically got fixed, and it is not going to be changed again further. So right now here how the strings basically forms, it is like double a b b, and from here it is like a and double b and b. If we try to add extra b, we will just go out of bond, so this is not a valid one. So whatever the previous b a b b is going to be, it is going to be fixed. From a also if I try to add b, it's not going to be having length k equals to 4. So this is not also valid one. From there it is going to become 0 as value. From here, since it is coming to, we have to make sure that we have to go into that particular index. So what is that index? Dp of, so whatever the previous dp that we have, this was the dp values that we have previously. So dp of k minus this b's count. Okay, b's count minus 1. Okay, whatever the value has been there, because from there only, that particular location we started it. So that is something what we have to keep on cutting down. Okay, that is something what we have to subtract it. Previously it was 1, then 1 and 1, so on, something, those values is something what we have to cut down, so that repetition is not happening at this particular location. Okay, that's how we can simply solve this particular question. It's bit tricky. Obviously we have to solve some of the unbounded, knapsack, and sliding window techniques also we have used in this particular one. But yes, with the time you get clarity. Just try to solve this one and then solve dp of unbounded and abstract problems as well. You will get the clarity. Right now I'll just try to write down the solution as well. So the first thing that we will do is, we'll get the length int n equals to word dot length. This particular one I just started pushing it because my throat is actually paining. I already speak a lot in the morning. Yes, I have to make sure that everything is perfect. So I just started writing those solution again without giving further explanation into that one. So next thing is like, let's try to get all the counts frequencies. So we can create array list here. List equals new array list. In this list, let's try to get the count. So let me create a count pointer here. I equals to 0. This will be like pointing till n. And inside here, let's create j equals to I plus 1. Okay, while this j is actually less than n, and uh, whatever the character that is there, word dot char at I, if it is equals to word dot char at j, if that is the case, we simply increment these j counters. The moment we see that different characters are been there, okay, we simply update it into the list. Okay, so for whatever the count that we got, j minus I is the difference that we have. So that is something what we will update, and I value will get updated with the j. Okay, that way the loop will keep on going, and the unique elements only, the counts of those unique elements we will get it. So if it is like a b, so currently I started here, j point keep on pointing. The moment j pointed to b, we are done. We will exit from this while loop, and in the list we will add the difference. So it is like 3 is the values first it get added, then it is like 4 is the value it get added. Okay, this way the values been added into the list. Now we have created the list which will maintain all the frequencies counts of each characters. And after this, the first thing is like, let's try to get total number of possibilities, right? So I'll create a long variable total. In this total, let's start with 0. Sorry, it should point to 1. Int I equals to, let's try to get the nums from directly from this list. And total should get updated with total into this num, and modulo is something what we will add it at the end. Okay, so let's try to create the mod as well. Mod equals 1 0 2 3 4 5 6 7 8 9. Okay, so we got the total. We will simply check that if k, whatever the k, if it is less than or equals to this list dot size. This is also I already cleared you guys. So if k value is less than or equals to this, whatever the total different characters that we have, we can simply return this total. Okay, we don't have to worry about removing any invalid strings or not, because all are going to be valid one. So it should be converted into the int. Okay, if not, we have to figure out the invalid one, and we have to make sure that we collect all the invalid strings. The first thing that we will do is, we will create a dp int dp equals new int dp, and this value is having length k. Dp of 0 is basically updated with 1. Okay, now what we'll do is, we'll run a for loop for int the counts. Basically I'll get it from this list. Okay, let's suppose a's count is basically 2, b's count is, so those counts we will get it, and we'll try to run a for loop. And that for loop is basically start from let's say j equals to 0, or we can start it from the 1, because at 0th index every time we have noticed 0 value is something what we have filled. We don't have to worry about that one. J less than k and j plus plus. So because till k, whatever the invalid strings that we get it, those are something what we are trying to figure out by counting them. Now at this location, let's try to create. So at same point in time only, I'm just trying to get all the side as well as upper left side's values. I'll create a sum variable here, sum equals to 0. Let's create another dp array, which will be new dp array, new dp. Okay, in this new dp, the length is again same. This new dp, the moment we created this new dp, we will update this with previous one. Okay, so basically, I just want to add some values, sum, because whatever the counts that we are getting it, that is something what I keep on adding it into this sum. Sum equals sum plus dp of what is that value? Dp of j minus 1. Okay, j minus 1, whatever the previous. So this one was the previous dp state. New dp state is something what we will create for each characters. The moment new dp state is created for next character, this new dp state is going to be the previous one. Okay, we have added this one. The first condition we check is if this whatever the counts, if this counts is basically less than this j. Okay, at that point in time, I just explain you that from this sum we just simply subtract dp of j minus counts minus 1. Okay, this value, so that we will make sure to not have all the different combinations. So whatever the counts that we are getting it, they are not going to be repeated one. Modulo is something what I'll add it. Before adding modulo, let me add the mod here, because sometimes this value may go into negative as well. So yes, we have taken care all the different values. I tried running it without mod. Okay, I got some errors, that's why I have added these mods and all. So this is done. Now this way we will get all the values, and let me update this new dp of each index. Dp of this j equals, let's convert this sum into this end, because dp is basically end. Now the moment this is done, this for loop, once it is completed, whatever the previous dp that was there, we will simply update it with this new dp. Okay, I am not copying that data, because simply this new dp is basically again pointing to another memory areas. So yes, we can simply do it like this way as well. But if new dp was also outside, and at any point in time if we tried modifying it, this dp also get modified. Okay, we have to make sure all those things as well. Now the moment this is done, we will get all the invalid information into this particular dp array. Okay, let me see if it is getting updated. Okay, it is getting updated. Okay, so in this dp we got all the invalid counts. Now the moment we got that, let me create here another long invalid. Okay, it will be pointing to 0, so we'll run a for loop for int. So here at this moment I can start from the 0th index as well, and we can add all the dp's values to get it, or else we can start from the size, list dot size, because from there only we start getting different values. So whatever the list dot size we have, this should start running, and j should be less than the k. J plus plus, we will simply add it into this invalid. Invalid equals to invalid plus dp of j. Okay, let's add the mod as well. So any operations that we are doing it, we have to make sure that we will use this modulo operator. Now that's all. We got all the invalid counts as well. We will simply return the form of int total minus invalid. Sorry, it's lagging a bit. Invalid plus mod. Again, I'm adding the mod because this value was getting negative. So yes, we have to make sure that that is not going out of bounds. So mod is something what we have added it, and modulo operator we added, and we are returning it. Let's try to run this code. Let's see if we have any issues. Okay, new dp. Okay, dpp was p was capital. Okay, I think that was the mistake, I guess. Let's try to see if we have any further issues. Okay, last questions answer got wrong. Same thing happened previously. See, this output was getting different because we are missing somewhere adding the mod operator. Okay, and that was this one, sum plus dp. After doing adding this dp of whatever the value, we should put the mod. I think this time it should work fine. Okay, it is working fine. Let us try to submit and see if it is working fine. And yes, If we try to think about the complexities, okay, it is working fine. So this particular while loop is running till the length of the string, so big O of n. Going ahead, it is like I mean, it hardly go till 26 characters at max, okay, because a or a to g, like in total 26 characters we may have. And yes, that's all for this particular for loop. If we consider here, it is like big O of k space complexity. And going ahead here, it is again this one running 26 times, and this is like k times, so 26 cross k is the complexity that we got max. This is again k times running, k minus whatever the list that we have. Okay, so far with this one, the complexity is like m cross k. M is basically less than 26 only, or equals to 26, and space is basically equals to big O of k plus big O of this 26. Okay, 26 is constant, so big O of k is the space that we have. Okay, I guess you guys get the understanding from this particular video. Just please make sure to like the video, and thank you for watching this one. Bye bye.